Okay, so here we're asked to solve a logarithmic equation. And the first step for solving a logarithmic equation is to write it as a single log. Now, they're both log base 2, so I can apply the product rule. So that plus, I'm going to change that into multiplication inside the argument of this log. So log base 2 of x times x minus 1. Okay, and that's going to equal 1. Now, at this point, I have two sides that are equal. So what I'm going to do is, well, what we could do is apply the definition. 2 to this power has to equal that argument. That'll work. Another way to do this is to use the one-to-one property for exponentials and raise both of these equal sides to that base. So base 2, if we use those equal sides as an exponent, those quantities raised to the 2 power is going to be equal. OK, so 2 raised to the log base 2 power, those are inverses, so they kind of cancel, and I get x times x minus 1 equals 2 to the 1 power. Notice that's the same thing you get from the definition anyway. What's left here is just a simple quadratic, and I can solve that. So the first thing I'm going to do is go ahead and distribute the x, and then get it in standard form. So x squared minus x minus 2 equals 0. Now at this point I can use the quadratic formula, but I do think this one actually factors. So let's go ahead and try to do that. First term first, x and x. 2 breaks up as 1 times 2. And I need it to add up to -1. So the 2 better be negative, and the 1 better be positive. 1 times -2 is -2. Yeah, it factors. OK? And then we'll take each factor and set it equal to 0, right? So x plus 1 equals 0, or x minus 2 equals 0. And here we get 2 possible solutions, x equals -1 or x equals 2. Now, there's a little bit of a problem with -1. If I plug -1 back into the original, I have log of a negative number. And that's a domain error. You can try that on your calculator. The domain of the logarithm is only allowed to be positive numbers, so this one's extraneous. And I'll just go ahead and toss that. Now, when I check 2, I can plug it in and see that it does work. So we did get one solution on this one, x equals 2. So you want to look out for that. When you apply the definition or use the one-to-one property for exponentials, you do introduce the possibility for extraneous solutions. So do check.